Hi, in this video we're going to look at the GCSE higher topic of vectors. If you would like any more information, you can of course follow me on Twitter at Mr_G_Walton and our school account at Tuckton Maths. So in particular in this video we're going to try and understand what a vector is. We're going to be able to calculate some simple vector relationships, and then we'll have a look at some exam style questions where we're going to express more complex roots in terms of vectors. Okay, let's make a start. So you'll see most questions in terms of GCSE expressed in terms of triangles, and a vector is simply a path. So if I started here, let's say that this is O, let's call this place here P, and this place here Q. If I wanted to walk along this route from O to P, so I'm going this direction, you might see a little arrow here, and we could call this vector A. Now, in examples written down, you might see this as a bold A or A with an underline underneath it. And what this A, this vector, is representing is the direction from O to P, up here, as well as this exact length, O to P. Okay. Let's think about another one. What if we were going from O to Q? Well, you can clearly see that this is in a different direction to O to P, and it's also a different length. Now, it didn't matter whether it's a different length. The fact that the direction is different is enough, but actually the length is different too on this one. So we'll call this one vector B. So if I'm trying to go from O to P, I can follow the vector A. And actually, the vector A, if I were to draw another one, if it's parallel and the same length, it doesn't actually matter whether it's here, or if it's here, or here, or in fact here. This is still the vector A. Okay, so it doesn't matter exactly where it is, as long as it's exactly the same length and travelling the same direction and travelling parallel to our given vector. Okay, this is O to Q, and we call this one vector B. Now, if I wanted to get from, let's say, P to Q, so if I wanted to go from here down here, well, rather than expressing this as a new vector, is there an alternative way I could have gone from P to Q? Well, yes, there is. I could have gone along here and then along here. Now, along here, you're saying is vector A, but actually, look at the direction of the arrow. The arrow for vector A is only in this direction, so from left to right. If I want to travel the opposite direction, I can do, but I'd have to call it minus A. So if I wanted to go in the opposite direction, down here, I can call it minus A. As long as the length is the same, and as long as it's parallel, and I'm travelling in an alternative direction, the opposite direction, I can call it minus. So far, I can go along here, minus A, and along here, positive B. So I could say that P to Q, and we write this like this, P, Q, the little arrow above, just means going from P to Q. I can say is minus A plus B. And I can tidy that up a little bit more by saying it's the same as B minus A. Okay, so all I've done there is just rearrange the algebra just a little bit. So I've rearranged this to be positive B, this is negative A, I've just moved it over. And we can do this. So in the same way that we can deal with normal algebra in terms of multiplying something by 2, I might call this a length. If it was twice as long, I could call it 2A. Or if I said that this part here is a third of the way along, I'll call this place here R. I might say that O to R is a third A, as long as I'm travelling in this direction. Okay, so these are the fundamentals. We're following a path. If it's in the right direction, then it's positive according to whatever the vector is. If we go in the opposite way, it's negative. If it's exactly the same length, it's this length here, 1a if you prefer. If you go in a third of the way, and in this direction we can say it's a third a. If we were going twice as far, we could call it 2a. If we're starting up here and coming all the way back twice as far, we can say it's minus 2a, and so on and so on. Okay, let's have a look at an actual example. Right, in this diagram we can see that we've got some places O, A and B. We can also see that O to A is represented by this vector here, A, and O to B is represented by the vector B. The first question says find AB in terms of A and B. So I want to go from here to here, but we're doing it in terms of these vectors. So first of all, I'm looking and I'm saying, okay, I need to be starting at A. So A, B, with an arrow above to denote which way I'm going, can be defined as this way. Now, notice the arrow here is pointing as if OA is the vector A. If I'm going AO, I need minus A. So minus A. I'm now at O, and I'm going along here to B, which is the vector B. So plus B. I can tidy this up just like I did on the last slide to B minus A. Done that one. Okay, let's move on to look at the next part then. It says the point P on AB, here it is such that A to P is a third of A to B. So if the whole thing here is B minus A, this is a third of the way along it. Okay, it says find O to P in terms of A and B. Well, O to P, I want to go from here to here. This part is A. So O to P is A. Now, how do I find the next part? Well, I've gone a third of the way along AB, and I know that AB is B minus A. So this is plus, because I'm going in the right direction, I'm going down here, which is what AB says. So plus a third B minus A. Now, it doesn't tell us to tidy this up at all, so I could leave it in this form. If it did say to leave your answer in a simpler form, then we could of course multiply at the bracket and collect our like terms together. So just for completeness, I'm going to do that, and I'm going to do it up here so you can see. O to P would be A plus a third B minus a third A. So I've multiplied out my bracket a third times B and a third times minus A. Now I can collect my like terms together. If I've got A minus a third A, I've got 2/3 A plus a third B. Now you might argue that that's tidier than this. Either way, they're both exactly the same as each other. Okay, let's move on to a further example then. In this example, it tells us about the triangle ORS. O to R to S. And it says the point T is along RT such that RT is a quarter of RS. So it's a quarter of the way along. It tells us that vector OR is denoted by R and OS is denoted by S. First of all, it's asking us to find S to R. Okay, so again, let's think about how we can get from S to R using the vectors that we know. Well, we can go minus this way and plus this way, so we can write SR as being minus S plus R, or R minus S. Okay, that's the first part. Next one, S to T. Okay, so S to T. Well, we know that S to R was R minus S. So S to T, let's think about how we can label this up. this is going to be a quarter of the way along, and this is 3/4 of the way along. So what I'm interested in is s to t is 3/4 of the way along r minus s. Hang on, where did I get r minus s from? Well, that was the way that we can describe the vector s to r. So this whole vector s to r can be described as r minus s. That's the whole thing, going all the way along this direction. I only want 3/4 of that, so I can write it as 3/4 r minus s. Okay, I'd like you to have a go at this one. Pause the video, read the question really carefully, and have a go at this and see if you can tell me some of the things that are going on here in this diagram. Okay, so hopefully you've had a go at drawing this out, and you might have seen some things here. First of all, it says in the diagram, OC is 2 lots of C to A. So O to C is 2 lots of C to A. Right, okay. What else do we know? Well, we know that O to D is the same as 2 lots of D to B. Okay, and that this is described as O to A is described as 3A, as the vector 3A, all the way along. And we also know that O to B is defined as 3B, all the way along. Okay, what else did we know? Well, we knew that C to A was the same as 2 lots of... O to C was 2 lots of C to A. So that's like 3 parts, if you like. So that's like 1/3 of the way along, 2/3. So C is 2/3 of the way from O to A. What does it tell us about D? Well, let's have a think. Well, it's the same kind of thing, isn't it? It's like DB is a half of O to D, or O to D is twice D to B. So again, this is 1/3 of the way along, and this is 2/3 of the way along. Right, that means I can also start to split up my vector quantities, and you'll notice that at this point I haven't actually done any of the question at all. I'm just writing some things down that I know. So this here can be described as B. That's because 1/3 of 3B is just B, and this part along here can be described as 2B. Okay, so I've taken my 3B and I've split it up into B and 2B. Let's do the same on the other side, from O to C and C to A. Again, this part, I'll use a different colour again, just so that we can keep track of what's going on. Let's do this. So this nice purpley colour. Okay, so this is going to be along here, A, and this part up to C we can call 2A. Okay, let's have a look now. We should be able to find some things out. We want to know O to C. Okay, I've worked O to C out. O to C is this part 2A. A to B. Oh, okay. A to B. So I'm here, and I want to be down here. Well, that's got to be going all the way along here, which is minus 3A, all the way this way, plus 3B. So A to B is 3B minus 3A. Or, I might want to take a factor out just to keep it tidy. 3 lots of B minus A. Don't know if that might be useful later, we never know with these things. So I've written it down as 2 separate ways. Just put a little dashes underneath just to denote the vectors. Okay, C to D. How can we do C to D? Well, we know that C to O, or O to C, is 2A. So this is minus 2A this way, plus 2B this way. So C to D is, let's think, 2B minus 2A. Or, I'm going write it here, 2 lots of b minus a. Okay, let's think about what else we know then. State 2 facts about the relationship between AB and CD. Okay, this might be interesting. So AB is this line down here, and CD is this line down here. Okay, and it's in that direction that I'm interested in. Well, AB is the one that I found out before. AB was this one, and CD was this one. What do we notice that's the same? What do we notice that's different? Maybe that's a good way to think about it. Well, what's the same is that they're both described as B minus A. So they are, in fact, parallel to each other. We can tell they're parallel because they're both B minus A. One's 2 lots of B minus A, and one's 3 lots of B minus A. So one of the facts is that they are parallel. Another fact is that CD is, let's have a look, well, it's 2/3 of AB is 2/3 of the length AB. Alternatively, you might have described it the other way. You might have said that AB is 1.5 times as long as CD. Either of these things are fine. Okay, if you manage to get some of these things right, really well done. It's not easy. I think that when we're doing these, it's always worth annotating your picture, thinking about what you can find out, then going through the questions one at a time. In this case, I'd actually done a lot of the work before actually reading the question, but just read the questions carefully. Make sure that you're thinking about which way the arrows are going. For example, if it says O to C, make sure you are defining it from O to C, or if it's O to A, make sure you're doing it all the way up to A. Okay. So as ever, when we're doing revision card notes at the end of the video, it's worthwhile making a note of some of these things. So a vector is all about the length and direction from one place to another. These are all straight lines as well, by the way. Check for which way the arrow's pointing. Think about walking along these routes if there's different ways of doing it, and annotate your diagram with bits of information. And if you want to draw yourself a picture, a really good picture to draw would be one with a triangle, where you've got something like O, A, B, and O to A, we might say, is the vector A, O to B is the vector B, which means to get from A to B, we can call that B minus A. Okay, and we've seen that twice in the video so far. If you want to write yourself some little notes on these as well, feel free to do so. This is a difficult topic, so if you've managed to get all the way to the end of the video and you're understanding it, really well done. It might be one of those ones that you want to go back and watch a few times. There's quite often a GCSE question on vectors. It's not easy. The next time you're going to come across this will be when you're doing your A-levels, and probably not until year 13, so don't worry if you're finding it a tricky topic and one of those that you need to do that extra little bit of work on. Keep working at it, you will get there. As ever, good luck with any exams that you've got coming up, and if you need anything, get in touch. Okay, bye.